so I hope everyone's enjoying their morning so far and learning a lot, and we've still got a lot left to learn. But now it's our turn to present. We did our project over the absorption of substances through skin. My name is Zane, this is Ethan, and this is Ron.
Have you ever wondered what the real purpose of skin is? How many of you use lotion, makeup, ointment, or anything else you use for your skin? Well, did you know the skin is the biggest organ and acts as the first level of defense in your body? It keeps out environmental factors and protects your organs. Skin also plays a different role in other situations like cooking. However, some substances can't go through your skin. First, let me give you some info about the skin. The epidermis is the outermost layer of the skin, along with the dermis and the hypodermis. The epidermis helps protect you from the sunlight, temperature, and diseases. When things are absorbed through your skin, it travels into your bloodstream throughout your whole body. We have 3 different types of skin: chicken, turkey, and pig. And 3 substances: water as control, oil, and saturated salt water. We have 3 shells and pour 5 milliliters of each substance on top of the skin and checked it in 24 hours. We measured the substance on top and what was left in the bottom of the beaker, or inside the beaker.
To expand on how this was set up, we set up a grid. On top you have the 3 different types of skins, and on the left you have our 3 different substances. Each skin was matched up with each substance, which provided 9 groups. 1, 2, 3, 4, 9. That counts. 1, 2, 3, 4, 9. And this is how we set up our apparatus. You can see we just simply placed the skin on top of the beaker and then placed our substance in the center area of the skin. And we waited 24 hours, and these pictures are the results we got. This is the chicken skin. The previous slide was the pig skin. This is the turkey skin. And there were several trends that we noticed visually. You'll notice that especially on the salt water and the regular water, there was a lot of discoloration. The skin became very light colored, and all areas except in the center of the skin where our substance was placed dried out and became more stiff, while the center area remained much softer and moist. This chart represents the amount of substance that remained on top of the skin after returning from 24 hours. And you can see that our oil, most of that stayed there. Nothing really happened to the oil. This is the amount of substance that we found in the beakers after 24 hours. The control, water, was the main substance that made it through the skin and into the beaker. But there were also a lot of substances that went unaccounted for. This means it was neither in the beaker or on top of the skin, but we poured 5 milliliters onto each apparatus, each group. The oil, for the most part, was all there. It was mostly on top of the skin, but for the control of water and salt water, there were some differences.
So let's get to the discussion. What happened during our experiment? Well, there was obvious discoloration. You saw that. We attribute most of the discoloration to that the substance wasn't on, to the skin drying out, which was, as I think I hold over here, disgusting. Pretty awesome though, right? So there was also the spot where it was, it kind of bleached it in the center. I don't know, like, if I didn't compare whether the beginning and the end, if the skin actually changed color there, but it was obvious that it was still moisturized there and resulted in a lighter skin tone than the rest of the skin. As you saw through our graphs, most of the penetration was from water, and oil didn't end up in the bottom of the beaker. Most of the oil remained on the skin, and we did have a lot of amounts unaccounted for. because we did leave it over a course of 24 hours, but not the oil. The oil kind of doesn't evaporate. So I'm going to go ahead and recap. Water was absorbed, and this is thanks to the skin barrier function. The skin barrier function is the skin's function to try to maintain a certain amount of, keep the skin from, or keep the body from drying out, and also prevent the body from becoming too flush with water. We think that the skin didn't go, the oil didn't go all the way through the skin because the skin was to already have lipids in it. It may have been absorbed by the skin, but we're pretty sure it didn't evaporate and it didn't end up in the bottom. So you sit here and you're like, so what does this disgusting chicken ham talking thing have to do with real life? Well, what we were doing is testing the ability of the epidermis to absorb various substances, which was a salt-water mixture of pure water and oil. And this has major benefits in medicine, skin treatment, and in your diet. We used the brine for the diet because we wanted to see what would happen if, like during marination or cooking, what would happen to the liquids or the substances over time. And also because there's a function of, for some reason, skin absorbs more of a substance when it's got a high water, when it's accompanied by a high water concentration. Skin treatment, as you could see, almost everyone around you had their hands raised when they said that they used some kind of product on their skin. This could help with the effectiveness of those products and lead to further developments in those products. And medicine. There are some kinds of medicines, such as eczema, or some kinds of ailments that you apply your medicine to your skin and it's absorbed through the skin to help that area and eventually the whole body. So in our future experiments, we could use fresher skin, a better controlled environment. We could check on intervals, like hourly intervals. We could use more substances and more skins, and we could use more skin for each trial. Here are our references. These helped us make our decisions with the skins and helped us explain what was going on in the experiment. Do we have any questions or comments?
Why do you think the skin changed color?
The skin changed color. We believe the skin changed color because most of it, the skin didn't have substance on it, liquid, so therefore it dried out. Is that your question? Does that answer?
In the middle, how it was like bleached or whatever?
It may have just been the contrast between the middle and the outside, but it could have also done it just because it may have had absorbed a lot of liquid and become lighter because of that. Anyone else?
Do you think there's any other ways that the substances could have disappeared besides evaporation or absorption of the skin itself?
Well, we could have had unaccounted for substances because, like minor errors in measurements, adhesion, cohesion, all that. But we don't see another way that it could have possibly disappeared. Anyone else?
We did notice that on one of the water groups, after the 24 hours, there's a little bit of oil from the fat in the skin floating on the water.
It looks as if the chicken and the turkey are maybe fresher, or more fresh than the pig.
I got you. Okay, so there was a minor error with the skin that we received. We failed to specify that it needed to be uncooked to to preserve the skin barrier function, and the ham skin was cooked and cured.
This of course could be expanded. You know, you may have noticed that a